Okay, so here is section 7-2, part 2. In this section, we are going to look at exponential regression. I don't know if you remember linear regression, where we take some actual data and we plot the points and we look at them, and if they look sort of linear, then we can run a regression that will give us an equation that is the line of best fit that best matches our data. Now we're going to do the same thing, only the function is going to be an exponential function, not a linear function. So you can see here that I have plotted some points. I just made up these points. So I've got 4 points, and if you look at them, they kind of look, actually let me zoom in a little bit. They kind of look exponential. So there you can see them. Okay, so there's like a curve. You can see it going up. So what I'm going to do, and these are the points, I'm going to put in a function here. So the function looks like this. So y1, and then I'm going to use this little thing here on my calculator, ab raised to the x1. And ta-da, there is a function. Now you can see right here, it doesn't exactly go through the line, the function, but it's a good fit. So you can see this is the line that best matches my 4 points. And over here, this is the value for A. This is the value for B that would make this function, that would define this function. So I could say that the function y equals 2.77 times 2.01 raised to the x power would give me this function. So let's try that. Let's put that function in. So y equals 2.77 times 2, I'm just going to round that to 2, raised to the x power. Ta-da! Almost perfect fit. Okay, so that is linear regression. Now let me take you back. I keep saying linear regression, I mean exponential regression. Yeah, exponential regression. Let me take you back to the book. In the book, there's an example that looks like this. Let me see if I can fit it in here so you can see it all. Looks like this. And so here we have this coffee example, the temperature of coffee. So the temperature is brewed starting between 195 and 205. In this case, 203 degrees when the coffee is first brewed. And then it's just sitting around and it's cooling. Okay, we want to know when will it be cool enough to drink. 185 degrees. So we can see that happens in the first 5 minutes. Okay, but here's some data. So somebody just kept taking the temperature of coffee for 30 minutes, and here's what the data looks like. You can see it's got a curve, it's exponential decay. Okay, so it kind of looks exponential, so that's good. All right, let's look at what comes next. So the next thing we're saying, well, we need to, in order to use the regression on the calculator, we need the asymptote to be 0. So since room temperature is 68 degrees, we're going to subtract 68 degrees because the coffee will settle in at 68. Actually, that's a little cool for me, but I guess that's the example that we're going to use. Okay, so we're just going to take everything and subtract 68. Now, they're doing this on the graphing calculator. We could do it in Desmos as well. But I don't know if you remember, but the way to put this into a graphing calculator, if you want to do that, is you hit the Stat key and then select Edit. Okay, and then you're going to put the data in that I had before. Here, this data. Put this into the calculator. This would be L1. This would be L2. Put the data into the calculator. All right, and then you can go to, you can go to the third column and go up to the header and put this formula into the header. And it will subtract 68 from all of the values in the second column. All right, and then we're going to run regression. So on the calculator, you do stat calc, and then you scroll over to the right, and you see calc. It's very hard to write with the mouse. Okay, and you choose exponential regression. Okay, I'm not sure what number that is. And you run your regression and it will give you this function. So we have A and B. Okay, so that's it. That's how that works. And then to get the temperature, what we need to do is then add 68, because we need to raise it back up by 68 degrees. And you can see here, the x's are going by tenths, and we need that level of detail in order to find the right answer for our problem, which is when will it get to 185? Somewhere between 3 and 3.1 minutes. Okay, so there's another example of linear regression. Okay.